So we just want to show you what an experiment is going to look like for evaporation. And you can see that we have our balance set up already. Each of these cups has 100 milliliters of water in it and a thermometer to have a starting temperature. As you recall from third grade, the density of water is 1, which means that 1 gram of water takes up the space of 1 milliliter of water. So I know that I have 100 grams on each side because I have measured out 100 milliliters with my beaker in setting this up. So you have a data table, and we will be sharing the results with you. But the mechanism is going to be that we'll have a light bulb on one side. Obviously, the temperature should change. You should be thinking about how. We'll share that data with you later. And then as a result of the temperature changing and time elapsing, the volume will probably also change, and we'll be sharing that data with you as well. But we just wanted to give you a visual before we began.
Right. And then as what we are thinking about with this setup, our focus question that's going along with this investigation is, how does water vapor get into the air? So I want you to be thinking about that question. How does water vapor get into the air? Thinking about this setup with the 2 cups with 100 milliliters of water, and one of those cups will be under the lamp. Okay.
See you after. What do you notice about the scale? Look at the arrow. The left-hand side, not underneath the light bulb, is now lower than the right-hand side. They were equal to begin with. What would cause the right-hand side to now have less mass and less volume than the left-hand side? So here's a look at our data. As you can see in yellow, this represents the data underneath the light or lamp, and the gray area represents data that was not underneath the light. And you can see that under the light, that the temperature is increasing throughout the day. The area not under the lamp is also increasing, but not as great of a rate. And we're able to see that in the first graph that we're looking at. In the second graph, we're able to see the change in volume or mass. Remember, they would be the same because of the property of water with a density of 1, mass is equal to volume. And we're able to see that there's no change in mass without the light, the blue line. There is a decrease in water mass in the liquid form with the red line. So you are familiar with the water cycle. You know that this represents a phase change from liquid water that we can see to water vapor, the gas form that we cannot. The process of going from liquid to water to gas is called evaporation. And temperature is impacting and implicit here. So as temperature increases, the water temperature increases, and then it becomes the gas form. So the changes of state involved are liquid and gas. Condensation that we've previously studied is the opposite, where we're going from the invisible water vapor to the liquid, and temperature decreases with that.